Okay, we're going to do a very quick exploratory factor analysis. We're going to go to analyze. We're going to go to dimension reduction. We're going to do factor. The first thing you've got to remember is the first half of exploratory factor analysis is exactly what we did with principal component analysis. So we're going to do that first part, principal component analysis, real fast without a lot of explanations. You can go back to the earlier section on that. But we're going to put our questions or items in there. You go to descriptives, coefficients, significance, determinant, KMO. I think that's all we need here. Continue. There's our extraction. There's our eigenvalue cutoff. Boom. And we should probably do the scree plot. That's so hard? No. And that's all we need for principal component analysis. Let's click OK and take a look at our output. So factor analysis, get up there, you factor analysis. So here's our correlation matrix or our R matrix. And it's got a million of those in there. We don't care about that. So number one, our KMO score is greater than 0.5, so that means our sample size is okay. Our Bartlett's test of sphericity is significant, which means there are at least two questions in there that are highly correlated. And this is how each of the questions or items loads up. So the extraction numbers are all pretty well in place. Remember, if any of these numbers are, all right, keeping going here. Remember, we're still in the PCA phase. Here is your money box. Again, so this tells us that with 4 new factors, eigenvalues all greater than 1, we can explain about 50% of the variance, which is not a very strong model. Again, we could have used the 5th factor. It adds about 4.3% of explained variance, which, you know, is better than a poke in the eye. But again, we only use the 4. Scrolling. Here's our scree plot. And again, this agrees with our above matrix table up there. Anything over 1, we're going to keep, which we did. All right, here's our component matrix box. So this first box, the component matrix, is kind of a warm-up. It shows you how well each question loads up under all the new components. But again, don't overly worry about this one because we're going to do some magic on it. So now we're moving into the exploratory factor analysis. From now on, I'm just going to call that EFA part of this research. Okay, so now that we know that there's 4 new components, we're going to go back to analyze, dimension reduction, factor, and go back to the extractions. We're going to fix number of extractions is going to be 4. Click OK. I'm sorry, continue. All right, this is where it gets kind of sticky. We're going to go rotation, and we always pick the direct Obermann because we're assuming that there's going to be some kind of mild correlation between our new factors. That this is a glitch in SPSS. That's why we don't automatically pick the orthogonal or the Varimax, because if you do pick the Varimax, the SPSS will not put out the new factor correlation table, and that's what we have to check. All right, click continue. All right, and because we're in EFA, we're going to click save as new variables, save as a variable, because that's going to tell us exactly what is in each of the 4 new factors. Continue. All right, now we go to options. We're gonna click this, suppress small coefficients. Now this number right here, it depends on which book you read. Some books say 0.3, which is a lot more looser. Here at our school, we use 0.4. It's a little bit more structured, so we're going to use 0.4 as the cutoff. Continue. Click OK. And let me get this thing straight. Please hold. Yeah. Output time. So here's our factor analysis. Here's our correlation box or matrix or R matrix, depending on whatever you want to call it. Now, you'll notice there's a ton of correlations in here. So unless you're specifically interested in one specific question correlating with another one, you could use that information here, but we're not going to do that. We're going to go scroll down to, first of all, this box, the KMO and the Bartlett's test. Same thing from our PCA, principal component analysis. Sample size is fine, and we have at least one significantly correlated set of questions. Commonalities are the same. Variance explained should be the same. Scree plot should be the same. Component matrix. So you'll notice this component matrix box is a little bit different. The reason is because we click that suppress the smaller component. So if the component load up was less than 0.4, it will not show here. But again, this is not the box we're going to be looking for. The one we want to look at is the rotated component matrix table. But before we do that, we have to look at the correlation matrix table between the new factors. So let's scroll down. That's usually at the very bottom of the document. And hold on, there it is. Let me pull this up a little bit. Okay, so this is the box that's going to tell us if we should have used the oblique rotation or the orthogonal. So looking at the correlations here, the only one that is semi-significant is this one, negative 4.64. So in other words, the new factor 3, new factor 4, they are semi-strongly correlated in a negative fashion, which means that overall, most of our new factors, are not very correlated. In other words, that they are indeed orthogonal. Therefore, we're going to rerun this with an orthogonal rotation. So you're going to go back to analyze, dimension reduction, factor. Everything should be the same, but we're going to go to rotation. We're going to change that to the varimax and click continue. Click OK. So we're just going to look at the rotated extraction table, the varimax. Please hold. The rest of this stuff should be the same. That's still the same. And there's the original component, which we don't look at. Here we go. So we're going to look at this one. This one will tell us basically under which new component each question should fall. So the first question should be loaded under factor 2, the second question under 4, etc., etc. All right, so we're looking now to make sure every question loads individually under one item. If it doesn't, you might want to think about getting rid of that question, because you want to remember that EFA is trying to purify your items there. So I'm just going down. Each question has basically one loading for component. I'm looking for missing loadings. I don't see any. Don't see any. Don't see any. And I don't see any what I call pairs. In other words, this question could have like a negative 0.67 here, so it's not clear which one it loads up. But I'm not seeing any of those there. And just double checking, I did notice, actually my copy didn't notice, but this one question loads up under factor 1 and 2, so you have to make a choice. Normally we just go by the bigger value, so I would take this question and load it up under number 2 there. Okay, now we got to figure out which questions load up under which of the new components in order to run a reliability on each of the new factors. So hold on one second. So I simply wrote down which of the questions load up under which of the factors, okay? So factor 1 has all these questions, factor 2 has all these questions, etc., etc. So now we're going to run a reliability test on each of the factors. Please hold. So we go to Analyze. We go to Scale this time. We're going to click on Reliability. I hope you guys can see that. Let me move this over a little bit so you can see that. Analyze. Scale, reliability, and we're going to take, all right, so you should right click on these guys, change it to display variables. That puts their numbers up. So I can't remember which ones they were, so let me refer back to my Excel. So it's 6, 7, 10, 13, 6, 7, 10, 13, 6, 7, 10, 13, and who else was it? Please hold. 14, 15, 18. 14, 15, and 18. Okay, and basically we just want the item, scale. Scale if item deleted. Scale means Cronbach's alpha. And the correlations. Okay, so this is going to tell us the reliability of factor 1. Click OK. Keep your fingers crossed. So this is how many there were. 2,571. That's a lot. And our Cronbach's alpha was very high, 0.821.
The first number, not the second.
Thank you for the correction. This is the Cronbach's alpha, 0.823, which is very, very strong. We're looking for a cutoff of usually 0.7, depending which book you look at. So that means that those questions are correlated strong enough to be considered reliable. Okay, so we're going to repeat this with each of the other factors. Please hold. Okay, the second one has questions 1, 3, 4, 5, 12, 16, 20, and 21. Please hold while I put them in. Analyze. Scale, reliability. Kick these out. Stick the other ones in. Right click. Display variables. And
It's Leo, not Leo.
don't forget to check the statistics. We always want the item, the scale, that's the reliability score, the scale if deleted, and we want the correlations, and I think that's it. Click continue, click OK, let's see what it says. Okay, we have an issue with factor number 2 is Cronbach's alpha is less than 0.07. So what we're going to go down here is what it would look like if some of the items are deleted, and that would hopefully would strengthen our Cronbach's alpha. Okay, so this is a very important box here. If your Cronbach's alpha is less than 0.07, this box will tell you. I'm sorry. If your Cronbach's alpha is less than 0.7, I'm old. Get off my back. This one will tell you which question that you might want to think about deleting to increase your Cronbach's alpha. So this last column, it'll give you your new Cronbach's alpha value if you deleted this question. So I'm looking at this one right here, 0.8. Let's look at the rest of them. No, that's it. So in other words, if we deleted this one question, standard deviations excite me, that would kick up our Cronbach's alpha for factor analysis 2 up to 0.8, and that's what we're going to do. So please hold. All right, so that is question number 3. So we're going to reanalyze. Let's go back up to analyze again. Analyze. Scale. Reliability. We're going to kick out number 3. Everything else should be the same. We're going to click OK. So our new Cronbach's alpha is perfect. It's perfect. It's 0.8. So we're good to go. So now we know that the factor 2 reliability is acceptable once we threw out that one question. So let's do the last 2 real quick. All right, so factor 3 is kind of easy. There's only 3 questions, 8, 11, and 17. So we're going to go to Analyze, Scale, Reliability. We're going to reset this, right-click, 8, 11, and 17. There's 8, 11, and 17. Click OK. Statistics. Item. Scale. Scaled if deleted. Correlations. Good to go. Continue. Click OK. All right. So, wow. Factor number 3 is right where we need it to be. So 0.819, that's fine. So in other words, factor 3 has been confirmed to be reliable. Our last one is factor 4. We're going to go to Analyze, Scale Me. We're going to reset this bad boy. Factor 4 is question 9. 19. Get back in there, you. 22 and 23. Statistics. We want the item, the scale, correlation. That's okay. Continue. Okay. Please be good. And it's not good. But this is when we scroll down to the item. Oh, let me rephrase that. It's not good because it's less than 0.7. Okay, so our Cronbach's alpha for our last factor, would you know it, is not strong enough. So let's go back to the what happens if it's deleted table. And sorry, it's getting late in the day. So you'll look at these.
Yeah,
It's not good, right? It doesn't matter which one of these four you delete. You're simply going to,
have a lower.
yeah, it's going to lower your Cronbach's alpha. So what this means is that the reliability factor of factor 4 means it's not good. In other words, your factor 4 is not reliable. All right, one of the reasons that that last factor we could not fix was, if you remember back to the total sum of the explained variance, where's that bad boy? It was kind of weak, right? It only explained about 50% of the total variance. Give me a second, let me pull this up. Again, since we only kept four factors, it's only explaining about half the variance, 50% of the variance, which is relatively weak. Therefore, it should come to no surprise that your last factor, there is a very strong possibility that it will not attain the Cronbach's alpha that is necessary. So, in order to decide exactly how many new components should be extracted, that's when you would use the parallel analysis. But unfortunately, we're not going to do that in this video. So we're done. That's it. MGZ and Copilot. Bungity.
Bungity prelicious.
Bungity prelicious. We're out of here.